Good evening, ladies and gentlemen. Hope you are all staying safe and well. I am Eng.Aravinda and I'll be your host for this evening. It's evening for me, and I think it's not evening for you, sir.
It is the noon, half past
Noon,
12
yeah.
now.
Yeah. So I humbly welcome you all to the first session of the Innovations webinar series on behalf of the Electrical Engineering Society of University of Moratuwa. The Innovations team came from inventions and innovations, and we matched them up together to make innovations. So I think there's an audience at the moment. So let's move on and start the webinar. Firstly, we as the young electrical engineering community have minimal or non-existent exposure to the electrical engineering industry. There is a significant disparity between what we learn at the university and what we will be required to do after we enter the industry. It is a known fact that we can find engineers in almost every field who has started their career as electrical engineers. This showcases how versatile and potential an electrical engineer can be. So, in order for us to get there, we need help and guidance from those who came before. With the aim of bridging two decades, Innovations was conceptualized for sharing industrial experiences, expertise, and exposure of the professionals in the electrical engineering field with the undergraduates while promoting creativity and required soft skills to make us ready for future challenges. As the first phase of Innovations, we, as the Electrical Engineering Society of University of Moratuwa, have organized this Tech Talk webinar series in collaboration with the Institute of Engineers Sri Lanka. So now it is time to commence Innovations Tech Talk 1.0. For that, I cordially invite my fellow undergraduate Lakshani Patirage to welcome you all on behalf of the Electrical Engineering Society of University of Moratuwa. Lakshani.
Thank you, Janika. Good evening, everyone. On behalf of the Electrical Engineering Department and Electrical Engineering Society of University of Moratuwa, first and foremost, I would like to warmly welcome our today's session guest speaker, Engineer Aravinda Perera, and Engineer Nawodini Kankanamge, Dr. Rasara Samarasinghe, and Dr. Tushara Damayanti. Next up, I warmly welcome everyone from the IESL and Electrical Engineering Department who participated with us today to make this event a huge success. INVEN OVATIONS is a newly initiated concept which is focused on sharing industrial experiences, expertise, and exposure of middle-level field engineers with undergraduates while promoting creativity, required soft skills, innovation ideas to make us ready for future changes with the aim of bridging 2 decades. Today's topic is building the future starting from Sumanadasa Building. We are hoping to discuss about the process of evolving from being a graduate to an engineer, the essentials and challenges, and how to prepare as undergraduates to reach the global stage in engineering. As we all understand, this is a beneficial and novel opportunity for us as electrical engineering young undergraduates. Finally, I would like to say, listen carefully and grab the best from INVEN Ovation first episode. Stay tuned with us for many more. Thank you. Over to you, Janika.
Thank you, Lakshani. When talking about the electrical engineering industry, there are two institutions in Sri Lanka that we cannot forget. Those are the Ceylon Electricity Board and the Institute of Engineers Sri Lanka. To represent those two pioneering institutes, I invite Chief Engineer at Ceylon Electricity Board and Council Member of the IESL, Engineer Nawodini Kankanamge, to address the audience. Yes, sir.
Good evening, you all. Innovation or innovation is a concept which is focusing future engineers to find their best version inside their own self. You're sure then they all will become great life inventors one day. Of course, we have a lot of engineers who were produced inside the Sumanadasa Building and now at topmost engineering positions in worldwide. Yes, you don't need to invent the wheel again. Those who invented the wheel of the life will share their experience with you, how they have done that. You can use that experience as a ladder to get up quickly without seeking luck by chance. This series will create many local and international links with you, which will be making many opportunities in future. I'm sure Engineer Aravinda will be busy with his LinkedIn to accepting many invitations after this event. INVEN Ovation will be having series of similar events. Actually, this idea came to our mind during the recent field selection awareness session. I think all members of this organizing committee did good transformation that idea to reality. Meanwhile, we are very lucky to find more suitable speaker to charter this concept today. If anyone in this audience is really like or willing to expose or interact more with resources and field engineers, you can join with us as an event organizer of future events as well. I need to express our topmost gratitude to our teachers who made us and all 05 batchmates who are always encouraging us and connecting live with us today evening, and all staff members and you all. So without taking much time, we will move to the main session. MC, over to you.
We extend our gratitude to Engineer Navodana Kankanamge for creating this opportunity for our young minds to evolve. Next up, the main event of the day. Our guest speaker, Engineer Aravinda Perera, is a PhD fellow in the field of power electronics and electric drives at the Norwegian University of Science and Technology. Additionally, he runs a consultancy firm focusing on the Norwegian oil and gas sector. From 2012 to 2018, he worked for Siemens, Norway, where he held various positions, among others, the tech lead in Siemens global business for offshore oil and gas system studies. Some of the R&D projects he was involved in are electric and diesel electric vessels, direct electrical heating systems for subsea petroleum pipes, and the world's first ever megawatt scale subsea power grid. Engineer Aravinda Perera obtained a bachelor's degree from the University of Moratuwa and master's from NTNU, both in electrical engineering in 2009 and 2012, respectively. He has authored multiple scientific publications, including 4 patents for Siemens AG, Germany and USA. During his free time, he likes to read, blog, and play music. Let us recap his life in and out the university with the following short video clip. Sure.
Hello, Jayank. I don't hear you.
Sorry, I was muted for a while. Sorry. As for the video, we can see that here he's a great example to show what an electrical engineer can become. So without any further ado, I warmly welcome our honored guest speaker, Engineer Aravinda Perera, to Innovations Tech Talk 1.0. And I invite you to introduce us to the industry of electrical engineering and show us how we should prepare for it. Dear sir, over to you.
Thank you very much for that very flattering introduction. I have never been introduced like that, and that creates a lot of pressure to deliver now. I hope I will not disappoint your expectations. Uh, I have a presentation. Maybe I should share that. Let me try to do it. Did I manage to do it? Okay, let me try again. Okay. Do you no? Right. Do you see my presentation now?
Yes, sir.
Yes, sir.
Excellent.
Yes, sir, we can see.
Excellent. Yeah. Okay. Let me. Yeah. The title is pretty bold. Building the future. When I say the future, your future as undergraduate graduates, once you get the certificate from the Moratuwa University, your future is guaranteed. It's assured. Don't worry about that. If you now, I graduated in 2009. All my batchmates are doing very well compared to where they started. Now they are in flying colors, right? They are well settled. Your personal future is guaranteed as soon as you enter the Faculty of Engineering, Moratuwa. But I'm here to tell you that you hold the power to shape the future of the country where you live in, your mother country. But not only that, beyond that, you can even shape the future of the global trends, because you are sitting in a very powerful place, and you yourself is a very unique talent which you have not realized, that I'm going to tell you during the course of 1 hour. Sumanadasa Building is it's a beautiful place. You see I hope it looks still the same. It's not the prettiest building in the university, but definitely the place where you find the prettiest girls. I'm not sure if it's still true, uh, because of the architecture faculty. Uh, but this also holds the electrical engineering department, and which is a the founding engineering principle in modern engineering. We will talk about it later. But uh, I think I don't have to introduce myself again after that introduction. Uh, the whole presentation is broken into 3 parts. First part is some technical aspects and how my interested area is power electronics, and I will show how power electronics is applied in the industry based on my experiences. Uh, the remaining parts are more philosophic. It's and also you don't have solid answers for most of these things. I'm sharing my opinions, my philosophy, that what I believe in. Not necessarily that I knew them from the beginning, but I started to look back and fine tune things. And while looking at other countries, other graduates from other countries, I I got I would like to share this entire global or entirety perspective, which is kind of lacking when you you sit inside the university as an undergraduate. It's normal because you are just 20s, in your 20s. You haven't seen the world. You haven't interacted with other nationalities. But it's probably that is the reason why Navodhan invited me to share some of these experiences. And
Excuse me,
then,
sir.
yeah, do you
Sir,
have?
if it is possible, can we screen share the full? Can we have the full screen mode the presentation?
Isn't it in that mode?
No, sir.
Uh, is okay. Let me see. Isn't it not in the full? As far as I know, it's in the. Let me try again. So share screen.
In the
Okay,
PowerPoint
maybe
presentation,
this
so
one.
like in the left hand side bottom, there is a yeah, now good.
Do you see the full screen now?
Yes, sir.
Excellent. Yeah. Thanks for reminding that. Yeah. So this last two parts will be more philosophic, and I'm also I'm also gaining experience and still evolving, building myself. So in the meantime, it's there are certain things that I can share with you, but not necessarily that they are the gospel truth. There could be other opinions, other ideas. So that's why Navodhan, as Navodhan told, this will be a series of events. You need to listen to other experts or industry people also to before you uh, form your own opinions. Let's. So I have made I use this interactive question Q&A session. I know that when I talk to Sri Lankan students, I myself was like you. We are very inhibited people. We don't talk. We don't ask questions. But probably you have questions. So make sure that you make this event yourself and interact. Ideally, you can raise your question or directly ask the question, interrupt me and ask questions. But if you don't bother doing that, go to this link uh, from your phone or from mobile from your PC, paulev.com/Aravinda 496. Then you will see online platform where you can type your questions or points of discussion that I would like to address right there, and also make sure that either upvote or downvote others feedback or questions so that I take the most important ones, the most popular ones. Right. So let's go forward. Yeah. So let's look at the power electronic applications. Some of the based on some of my experiences. The first one is marine propulsion and electrification of marine systems. And Norway is a industry leader in marine systems, and electrified ships is is uh, is the state of art now, especially the diesel electric. Originally, the ships are diesel ships, diesel engine powered ships, but then it became diesel electric, and now it's moving towards full electric. I was involved in diesel electric phase, where I can show you. This is a if you see, this is a typical uh, uh, grid inside the ship, distribution grid. If you can see the main bus bar, let me use a pen, laser pointer, for example. Right. Do you see the laser pointer now?
Yes, Aravinda. You can.
Yes, good.
Yes, sir, we can see.
Yes. This is the DC grid, DC bus bar, and Siemens Norway holds the global responsibility for low voltage DC distribution systems. It is called Blue Drive and Blue Drive Plus C. These are the product names, and it's a very profitable business. And it's low voltage, 1000 volts DC, and this is the DC bus bar, as you may see. And for redundancy, you have several bus bars, and these are connected through a DC breaker. Now that is pretty interesting to have. I mean, there are a lot of challenges making a breaker for DC systems. For AC systems, the voltage crosses zero twice uh, in the switching period but DC systems are as it means it's always above zero. So breaking a DC system is challenging, and then you get power electronics systems to do that. We use solid state breakers to break the DC system, and what Siemens have developed, they got a breaker to break within 10 microseconds. It's pretty remarkable at that time. But in general, if you look at the whole system, you have the propulsion, thrusters, and all are supplied with power electronic converters, electric drives. And then you have the diesel generator in addition to the battery bank. Now, battery bank, typically there should be a converter here, DC-DC converter to interface the bus. But also there is this inverters to interface the generator to the bus. There are multiple advantages of going from AC distribution to DC distribution, because now the generators can run in their own frequencies. They don't have to be synchronized, and we don't need PLLs. You have the emissions are less, environmental friendly, and wear and tear is less, repair is less. So those are the motivations to move from AC distribution to DC distribution. So what I want to highlight is the importance of power electronics in this is a microgrid. I mean, microgrid is a buzzword. You can find that word everywhere today. But this is a typical microgrid, low inertia, quite many challenges with these kind of grids, and it's what the key takeaway for you is how much power electronics involved in such grids. It got single quadrant, two quadrant, four quadrant DC choppers, and then all three-phase inverters, thyristor rectifiers, active rectifiers, all kind of stuff here. So it's a very big business, and Trondheim, where I live, where the university is also, it attracts a lot of power electronic guys in this department. Then we move on to the let me turn on the right. And then other application that I would like to share with you is offshore oil and gas business, where you might be learning electric drives, right? That's a big topic in electrical engineering. And this is a industry application of electric drives, a megawatt scale in electric drives. And Siemens Trondheim also holds global responsibility in supplying these systems, but they don't develop drives. Siemens used to buy the drives from Pittsburgh, USA, or from Germany, or from China, all Siemens plants. But I can explain again how this application looks like. In Norway, the oil wealth is in the sea. It's in this. It's trapped under the seabed. It's not onshore. Like in Saudi Arabia, Saudi Arabia or in the Middle East countries, mostly the oil wealth is in the land. Whereas in Norway, there are other areas like Gulf of Mexico, or West of Africa, and also northeast area of Australia, where you find a lot of oil wealth on the seabed. And Norway has been having the technology to harness oil reserves from seabed is existent more than 100 years ago, but all mechanical. They used to have systems called Christmas trees. That's how the actuators, the valves, hydraulic and pneumatic valves have been using to harness seabed oil. But later, when electrical engineering was developing, especially the drives technology, IGBTs came in 1980s. Then slowly the mechanical systems got wiped out, got replaced by the electrical drives, and all. Now this is the state of the art state of the art to harness trapped seabed oil and gas. You need pumps or compressors based. If it's a gas reserve, you need compressor. If it's a oil reserve, it's a pump that you need mostly. But it could be a mix of things. There are a lot of other petroleum sciences behind it. But as an electrical engineering point of view, you have the pump. You need a motor for the pump. You need a motor for the pump, and that motor is standing on the seabed. This blue area is the sea, and that motor is standing on the seabed, and you send long cables from from a platform. This drive is standing on a platform. It could be floating on the sea, or uh, it could be stationary also. And then this length from the motor to the drive could be it's in kilometers typically, and the depth, water depth, it could be some 100 meters up to 1 kilometer also. Some it's around that region. Then that is the state of the art. And Siemens used to have they have two industry drives. One is this GH180. This is called perfect harmony variable speed drive, a multi-level cascaded multi-level topology, and the other one is GH150, and that is modular multi-level topology. If now the second one, B, if you look at the B structure here, this topology, you find two transformers. This topology B is more complicated than topology A because of the transformers. You need a subsea transform also now, and then that's because it's high, it's more power. It's around 20, yeah, in the high megawatt scale, whereas this is in the low megawatt scale. And then these drives are pretty advanced when it comes to control and adjusting the resonance frequencies, switching frequencies. Quite advanced drives and well mature also. This has been these drives have been developed in the 90s. And probably you can search, make a Google search and see Rubicon Perfect Harmony, and that's the drive. Siemens bought that company Rubicon. Right, that's about offshore oil and gas and the application of drives. Let me remove it. Then the next generation of oil and gas. This is, if you go to the previous slide, you need this long cable. And imagine you have several pumps, several loads. Then you will be in big trouble because you need cables for every load. And these cables are super expensive because it has the insulation, the mating. You can't have water touching the current, right? You have good insulation, and the connection points have to be mated, and the shielding, grounding. It's expensive, very expensive. So we would really like to get rid of as much as cables. These are called umbilicals, and now this is the next generation seabed oil harnessing method to place a power grid on the seabed itself, so that you send only one cable from the platform, which is in the 33 kV, 36 kV, 40 kV. It's in the mid kV range, and from there you distribute to several drives. And this has been a pioneering project from Siemens, and I was heavily involved in this project. It's very challenging, but also quite rewarding. to work in that. Right. And but I had this interest to do the PhD, and so I quit Siemens. I joined the PhD in the university to do a PhD. But in the meantime, I offer services, these services to mainly to Siemens and some other companies, uh, based on my experience. Uh, but most interesting thing for me is right now the PhD research. I like to take some minutes to explain what I'm doing in the research. It's a This is the title: sensorless, sensorless and adaptive control of multi-phase permanent magnet synchronous machines for deep sea mineral mining. The the application is now not oil and gas, but to mine minerals on the deep sea, on the seabed. It's a long story. While people were busy with oil and gas in the from 70s to 90s, China was strategic to acquire more than 90% of the minerals, especially the rare earth minerals around the world. So Europe and the Western world is now in a bit of a trouble because they are the China is holding kind of a monopoly in the supply chain. This is why Japan, South Korea, and many countries in Europe and also US have launched this seabed exploration for minerals. And minerals are very important, from mobile phones to ice creams. Full full package minerals are there. And when it comes to electric cars, you need lithium, you need cobalt, you need titanium, oh, you need aluminium, zinc. All these are found on the seabed. So there's a NTNU started a pilot project to investigate how to develop technology and also philosophy and law. It's a multidisciplinary project, and I am playing the drives part in it. But when it comes to drives, it's a huge topic when it comes to seabed mineral mining. You can you have space for multiple research areas. So what I focus towards sensorless control of machines, of multi-phase machines. But this uh, scope is valid for other applications also, like electric vehicles and electric aeroplanes, where you need high reliability, right? Traditionally, the technologies which have been mechanical or hydraulic are becoming slowly. They are becoming electric slowly due to the environmental aspects and economic aspects. So reliability plays a very important role in modern electric drives, and that's why I mean, we propose a multi-phase system, so that we have typically you have three phases in a motor. But what if you put six phases? What if you put nine phases? Then you get redundancy, right? If you look at the whole drive system, you have, when you say electric drive, you have several components. One is the motor. You are controlling a motor, right? And then you have uh, conver- uh, the three IGBT or the PWM inverter, three-phase inverter, and then the capacitor bank. If you look at all this full system, the weakest link of the whole system is capacitor bank and the converter, I would say. The converter switches, mostly IGBTs. Silicon carbide is emerging rapidly, but IGBT is the state of the art. IGBTs tend to fail due to temperature and various reasons. So if you look at the whole drive system, the weak link is the converter. What if one converter fails? In a six-phase machine, you have another set, so you can get at least 50% of the load if a converter fails. So that's the motivation behind making it multi-phase. Uh, and yeah, it's a bit of details there. Let me, but the challenging part is to make it sensorless. Sensorless control. What do you mean by sensorless? Let me talk after going to this slide. This looks a bit complicated, but it's let me guide through this. Yeah, some of you have already learned electric drives, taken the courses. At that time, it was Karnadas who taught us. So this is the mechanical load. You are driving yeah, you are trying to push a mechanical load through a motor. For vector controls or field-oriented control, that is the state of the art of control, you need the rotor position. You need to know where the rotor is every time, right? To decouple current and some fancy work there. But then to have a mode encoder here or resolver on the axis on the shaft is making the whole drive weak, because uh, drive becomes weak because it tends to fail. This because now the resolve is rotating. It has wear and tear. And for example, if imagine you put this whole system on the seabed and you have a failed sensor, you can't take it every now and then. Unlike say you have a sensor on your fan, if it fails, a serviceman can come and fix it. But if it's a sensor, small dam sensor on the seabed and it fails, you can't afford to fix it now and then, right? It's super expensive. Just to mention how expensive they are, to to hire a vessel to go offshore per day cost 50,000 US dollars, the rent minimum for one day, only for the vessel. So imagine you put engineers there and going there for 3 weeks. It's the business is unfeasible, right? So then you have to make sure it's you have redundancy, hardware redundancy, software redundancy, plus avoid the dubious sensors as much. Uh, and this is how. So you try to avoid that position sensor, but you need position. How do you do that? You estimate the position based on voltages and currents. That's what you do. Uh, and that's what you do in this block. But also there are other problems. The estimation fails if you use the back EMF at 0 speed. Then you don't have back EMF. Then you use another method called signal injection. You inject signals. That's what you do here. You inject signals and you read the anisotropy of the machine or machine's machine characteristics by injecting a high frequency signal, and you get that signal, treat that, and then you also again you get the position, rotor position. And looking at the speed region, you choose which speed which estimation you use, and then you do the use the sensorless control. That's how you do the sensorless. This is the state of the art sensorless control method. And then this block is doing the adaptive part. If temperature changes, especially on the seabed, it's so strange that you wouldn't believe that on a seabed it could be temperature could be 200 degrees plus, 300 degrees plus, because of volcanoes. And normally in Norwegian Sea, the minerals are found around volcanoes, and the temperatures can be 300 degrees easily. I'm sure this system will not be exposed to 300 degrees, but still temperatures can vary. It's not super cool on the seabed. It could be 20 degrees, 60 degrees, 80 degrees, and there are some currents, heat currents flowing. And if the temperature changes unnoticed, you will have the motor properties, parameters changing, like magnet strength, resistance, and then that will affect the control completely. It will completely mess the controls. So this block is trying to estimate the parameters of the motor online without any additional sensors, still with voltages and currents, and then that is fed into the system. So that is my PhD research. But in the meantime, I like to introduce this part also to you. It's a it's pretty interesting to know these things. I mean, at least to know the keywords for you. It's called a real time simulation. Now, probably you guys use Simulink for simulation. Am I right, Dantanarayan?
Yes, sir. Call me Janik.
Are you using Simulink? Or
Yeah, we are using
how
Simulink.
extensive? Right.
Just
Now,
started like a couple of semesters ago.
good. It's very important to know Simulink and to know the simulation tools. But when there are also limitations with Simulink and simulation. Simulink based PC based simulation is called offline simulation in general. What, because the systems are not connected to it, you model everything here uh, on your PC in the Simulink canvas. The challenges are that the time when the system becomes complex, it takes enormous amount of time to run your model. If you have algorithms, matrix inversions, it's getting really heavy. It can be, for example, to run my model in the PC, 10 seconds, it takes more than 1 hour. Uh, so to tackle this, there are the methods called uh, real-time digital simulation, RTDS, or digital real-time simulation. Digital real-time simulations have been introduced, uh, where you model it in FPGAs and multiple processors, so that you get the outcome immediately, real time. Real time means matching. If it's 10 seconds on your clock, you get the results 10 seconds, not scaling it like in offline simulation. But what we do is now, especially during this COVID time, I was not able to go to the lab. The university was closed, so what we did, uh, I developed this, modeled this in an system on chip. In a system on chip, you have both FPGA and the processors. What I did, I modeled this in the FPGA, such so that it's a real time. It becomes real time. And my professor and our team, we developed this control system in the processor, and this control system is an industrial control system. This can be used either in the emulated part or with the real machine system. And this embedded real-time simulator strategy is there are a lot of advantages. I just wanted to introduce this to you. But yeah, I think that concludes the technical part. Let me go to the next slide. Yes. If you have questions, maybe we can take them. I don't know how. Yeah, no, probably we should go. Looking at the time, we should go forward. Let me see if you have already put some questions. Yeah, I see some questions here. Yeah. Can we directly apply for a PhD in Norway after the BSc? So why did you? I felt that you want to do a PhD after working in this. Yeah. So what are the requirements to get a scholarship for this? Right. Maybe I take the most the most popular one. We can, if time permits, we can take other questions also. Uh, the question is, can we directly apply for a PhD in Norway after the BSc, after having first class or second upper? No, unfortunately. You have to have a master's degree in Norway. There are you have to have a master's degree from anywhere in the world. It doesn't matter. But in Norway, you need to have a master's degree before you apply for a PhD. But there are universities in US. I'm not sure, not in US, in Australia, where you can go for direct PhD. which I do not recommend. We can talk the details later. Right. Then we let me,
Excuse me, sir.
yeah.
We can continue this speech, sir. Then we are going to have the Q&A.
Right. I will. That's right.
Like,
Yeah. That's fine. Do you see the screen now? Do you see the presentation now?
Yes, sir.
Excellent.
yes, sir.
Yes. Okay. Now this section is now the question is from graduate to engineer. Is it's now we are coming touching the philosophical points, right? This is this section is for those who aspire to be engineers, right? Now don't get me wrong. Even though you are in engineering faculty, it doesn't mean that you are going to be an engineer one day. You can be bankers one day. If you look at my batchmates, they are either bankers or IT professionals, journalists, politicians, administrators, entrepreneurs. No matter what you do after the degree, you will do well because once you finish your degree, you get a paper called a certificate or a graduation. At the convocation, you get a certificate that you got an engineering degree. That will tell to the world that you have some brains, nothing else, right? Uh, you have some brains. You are a clever, hardworking guy. Afterwards, you are free to choose your career path, right? And when you are graduating from Moratuwa, I can assure that whatever you do, you will be successful, right? Normally, engineers are clever in other fields also. If you look at the, the recently retired the CEO from NDB Investment Bank, Vajira Kulatilaka, he's an engineer from Moratuwa. He spent all his career in investment banking. And if you know the most famous Aravinda Perera, it's not me. Most famous Aravinda Perera is the managing director of Sampath Bank. He's also a graduate from Moratuwa. So look at Mr. Bean. He's an engineer. Even Osama bin Laden was an engineer. So you can be prolific in whatever the field you go because you are clever, right? But what I'm addressing to those who aspire to be engineers after this, after the degree, after the graduation. Uh, now, before I venture into this, I have to explain to you what is electrical engineering. It's a huge domain. That is a challenge that you and I experienced 12, 13 years ago, and you are experiencing it now. Typically, if you look at big universities where over 20,000 students are there, electrical engineering is not a department, it's a faculty, right? It's a faculty where you have these portions, these departments: power, control, electronics, telecom, telematics, or computer science, in ICT and information security. So, but your department is not called power engineering, right? Your department is called electrical engineering. So the historical responsibility is lying on you to know electrical engineering. It's a huge domain, and the department holds the responsibility to teach you all, which is also challenging for the department. Now, if I look at my uh, transcripts, I have taken over 50 subjects. Yeah, 50 or more. Yeah, 50 subjects. You will also have to do these things in different fields because you are expected to know these things: power, control, tronic, telecom, everything. The challenge is that the opportunity is that you are so broad already, but the challenge is that you are not specialized in anything in the bachelor's degree, or you don't. This is not the case for electronics because they are already in a subtopic like this. computer science, they are already in the subtopic, but you are in electrical engineering, and that's why you have the freedom to learn computer science and electronic subjects also, and that freedom comes with a responsibility to learn a lot of subjects, and it's pretty broad, that you need to realize. And when it comes to power alone, which is only a subset of electrical engineering, you got still many areas to cover: high voltage, power systems, machines, power market. That's not part of the curriculum in Moratuwa. It's a big topic. And power electronics. And power electronics alone has its own world. And if you look at some universities, they are offering bachelor's degree in power electronics alone. There are some universities that offer master's degrees on power electronics alone. So the topics are so large and broad. Keep that in mind, because there's a historical responsibility vested on your shoulder to know the electrical engineering. Electrical engineering is the mother of all modern engineering, which you have to understand. And you are the torchbearers of this uh, uh, proud heritage, right? That's the starting point. Now I come to the topic. First, you have to understand. When I graduated, or when I was in the university, I thought engineer is in the picture A, wearing nice long sleeve shirts, sitting in AC rooms, uh, working with nice colleagues, laughing, drinking coffee. I found a job like that, and I realized it's not. If in case if you are working for 5 years in a job like A, you are not going to be an engineer. That I can guarantee, because engineer is, at least in the first 5 years, you have to apply what you learned in the university. Like in typically, I mean, if you want to be an engineer, you need to wear the, I mean, like a factory job, or you need to be in the lab burning your fingertips, soldering, measuring, heavy lifting things, fixing, servicing. That is electrical engineering. So in case if you have misunderstood, I'm sorry about it. I also have misunderstood myself when I finished my graduation. I expected this A type picture, but I got a job like that, and I realized it's not what will make me an engineer. In general, you need to understand that you are in an engineering field, right? My notion of engineering is, the simple basic notion of engineering is to apply physical laws within the physical boundaries for the benefit of nature. Physicists, theoretical physicists or applied physicists in who study physics, they will identify physics laws, but engineers are going to take the physical laws, and look at the physical boundaries and apply them in a very creative way, inventive way, right? Look at the electric motor, for example. Now, motor was this; it's an engineering product, but electromagnetism was not was existent in the world, in the universe. Electromagnetism was there, but it's the engineers who invented the machine to get some use, right? And then you have the physical boundaries. You have the speed limitations. You have the inductances. You have cross couplings. So those are the physical boundaries. So you are living inside the physical boundaries, but still you try to get some benefit out of it, out of the physical laws. That's what engineers do. Uh, so in my mind, engineer is an applicant. However, I have to tell that this is not everyone agrees with this. There are prolific engineers, prolific professors who are super clever, but they don't touch the implementation part, application part. They are very theoretical. They are very good in their simulation work. They they don't touch implementation part at all. They are in NTNU, they are in you can find them everywhere in the world. They might disagree with me, but this is my philosophy is that engineer must be able to apply the theory. Uh, then we move on to the other one is you need to realize that discipline versus application are two. Theory is one thing. Then you learn the discipline. For example, if you learn electric drives from Professor Karunadas, you will learn some classroom theories, right? So you get a job in electric vehicle development. When you apply these theories, you will realize the things are not probably exactly correct with what you learned in the classroom. Maybe they are correct on paper, but in practice you have to tweak things. And that application dominant knowledge is you will application specific knowledge you will gain when you work on one topic. But the funny thing is when you quit your electrical this EV job and you move to a washing machine company to develop a drive, you have to learn. You cannot transfer those most of that domain specific knowledge to machine machines. Then you have other topics, other challenges. The optimization is different, right? So you need to remember that theory is one thing. Then you go to you extract the discipline out of the theory and you apply. Once you apply, you will realize the priorities. Optimization is different. That's another key thing that you need to remember, and that's why you need when you this is part of the evolution of from graduate to engineer. You need to identify that, understand that application specific knowledge is also there in addition to the classroom theory. And then the life cycle experience. Probably this is what makes you makes you and me. When I tell these things, it doesn't mean that I have been a fully mature engineer. I have seen it. I am trying to involve myself as much in these cycles. When you do development, when you develop a product, you go through this cycle, right? Every cycle has its own engineering challenges, and to be fully mature, you have to involve yourself in all these levels. Typically, the concepts for development R&D teams come from the sales, because sales guys, for example, a big company like Siemens or ABB or GE, they have full cycle inside the same company, and then sales teams and R&D teams work hand in hand. Sales teams are very intelligent. They are not just talkers. They are truly sales engineers. They understand the systems pretty well. They understand the client's needs, and they also see a bit of future also. They see that sometimes clients cannot explain what they need, but the sales teams understand, okay, this might solve your problem. He will not tell that to the client, but he comes to the R&D and tell, hey, how about we release a product in 1 year? We have a big market, 600 million euro market. How about then you get the concept is tested a bit or argued a bit, then you do the development, then you do the testing, then you do a product qualification, because what you do in a lab is a prototype. You need to qualify that. Say you are developing a fan, a ceiling fan. It has to be consumer electronics qualified. It has to be earthing qualified, protection qualified. Those shock and vibration, all kinds of qualifications to be done in that domain. And then you do the integration part, how you integrate the fan with the plates and mechanical systems, and you do the sales. I believe once you go through the full life cycle, it takes. I could go through some parts in Siemens, but not all. It takes about 10 years, I would say, to go through this full cycle. And then this is the real game of an engineer, the art of optimization. I briefly touched this topic before also. I can give a classic example where I was involved in developing a DC-DC power supply. Now, if you look at the theory, it takes only 3-4 pages to explain one topology maximum. But when it comes to optimizing which area you are going to market, if it's the efficiency that is more important, or is it the high power density, or is it the reliability that is important, or is it the low development cost? There are multivariable objectives that you need to see. For example, if it's the most efficient solution you need, then it's one topology or one device setup, device class that you use. If it's the most reliable one, then it's a different world. If it's a low development, quick to market, then it's a different topic. It's this understanding is you need to get only you will get only when you develop things. When you do it on your own, you get hands on. So even big, major, very clever engineers fail in this one. I have experience that I was in this team developing the power supply. Then we had a very clever, very experienced engineer, very clever guy, but he didn't have this optimization mindset, and then the design was a failure. He made the most efficient solution while we needed a most reliable one. Of course, certain things are hand in hand connected, but this optimization is so once you develop the technological skills, you will also learn the commercial skills and innovation management skills. This falls into that part, and keep that in mind. Then then you have easy mounting, supply chain, mechanic. These are other aspects also that come into the picture if you dig deep into this topic. But keep that in mind. And now this is a very important bigger picture slide to show you what are the engineering jobs you find in the world, right? I mean, the x-axis, further you go, you have the more technical and theoretical hard skills are required, whereas we go up in the y-axis, you need more people skills and communication skills, right? I started my job here. I was a sales guy, and now I am in here because I understood I'm not. I mean, that's not what I am passionate about. This circle shows that, as far as I know, most of the jobs in Sri Lanka are falling in this circle. That's a bit unfortunate because that is also pretty typical. Like in Sri Lanka, you have all the world-class technologies. You have 5G, you have the Teslas, you have BMW, e-tron, and Airbus planes. You have the latest iPhones and Samsung Galaxies, and CEB, when they purchase from Siemens, ABB, and GE, and Philips, and all big companies. But the challenge is, do we know how they are made? Do we know the secrets? So if you are really passionate to know the secrets of developing them, you are pushed out of your country. That's unfortunate. That's a challenge. That, I mean, if you are really an aspiring engineer, there's only one company that comes to my mind now is this Vega. Probably I'm a bit outdated with this topic. Probably there are some companies, R&D companies, development companies that doing hands-on building products and product design. But I'm a keen follower of Vega, and what they do is quite impressive. It's world class. It's competitive. Really cool. If I were you, I would do all my strength to get an internship there, because you do the hands-on development. You are sitting here. Now, research, it's a funny word. you will find in Siemens, GE, ABB, and Schneider and all, you find R&D departments, but actually they don't do proper research. I have to tell you that research is normally done in the universities and research institutes. Universities mainly. If you are really cool, interested in research, you PhD is a nice place because you are allowed to do fancy research. Industries don't do fancy research. Their research or development is focused on a commercial aspect. They are looking at profit, so they don't look into the fancy, innovative, very free thinking way. Universities have that freedom because the money comes from the government or the taxpayers' money. So you are allowed to be fancy. Now, for example, big companies like Siemens, GE, they have this full full cycle. But there are some other for example, design studies is a very interesting topic. You don't develop anything, but you are using a lot of simulation tools to do that. But keep this in mind when you apply for jobs, uh, and when you will find fancy, very nice, interesting job posts applications. If they're asking for people skills, communication skills, then they are standing here, right? Of course, any job advertisement tells that you have to be a team player, blah blah blah. But to be honest, what I've seen in my life, if you are really clever in what you are doing, say you are a really good gate drive designer, or if you are really good non-linear control engineer, doesn't matter, you are an animal, they will hire you. That's how the world works. So what if you are in if your heart is towards this red zone, make sure that you learn things very well. Learn things, learn by doing, get hands on. But that's a dilemma that I have to explain, finish with this session with. Maybe as Lakshani told, we take the questions at the end. Then we move to the last part. Suit up for the global stage. That I'm asking you to be prepared, get your best suit, because you are born to do that. Let's see if I'm just joking here. I have been working with international teams, from people from Brazil to Iran to South Korea. And when I work with them, I realize that I compare myself with them, right? And I compare myself with my fellow batchmates. I'm definitely not the smartest from my batchmates. They are very super clever guys. So when I see, if I could, over time I realize I understand things faster than the others, and if I apply that to back to my Moratuwa batchmates, what I can conclude is, you guys, all of you, doesn't matter what your GPS stands right now, you guys are born Ferraris. When I say Ferraris, you are super fast in your cognitive skills. Remember that. Keep this in mind. Now, I'm not talking about nationalism. The Sri Lankans are the best in the world. Blah blah blah. No, I'm not talking about it. I'm talking. I'm telling this because I believe in any country there are 200 plus countries. In any country there is some percentage who are born with cognitive skills, better cognitive skills than average. And countries like India and Sri Lanka, if you look at the best universities, they manage to scrape all the best to that university, right? If you look, and also because of the hardships, the challenges, life, lack of opportunity, all want to become engineers or doctors. That does not help in the long run, but I can guarantee that you guys are born with that cognitive ability. You can understand, learn fast. You can understand complex things pretty faster, and that is in a global scale, not in the not only in Sri Lanka. In a global scale, you guys are very clever, and you are needed in the world. That has to be understood, right? You have But don't be proud. But that's a born thing, right? You didn't do anything. You are given with that. You haven't not that. You have done the hard work to get into the university, but remember that you are clever, very clever in a global scale. You are best in the world. Problem is, you are not tuned. This engine, Ferrari engine, is not well tuned yet. Your bachelor's degree will tune a bit, but it's your duty to tune further and further to get the best optimal, most optimal performance of yourself. That is number one. How good you are. You are very good, very clever. Keeping that in mind, we need to understand where the world is heading. The world in general, the developed countries are still fighting to develop further or to sustain their development, right? So then they are one. I'm telling you a secret. They are short of people. They are short of clever people. Today, the countries that pump the brains are India, Iran. It's insane to see how many Indians in the world in Western world. Insane. You check Infineon or you check Xilinx, Intel, IBM, Samsung, and Apple, Microsoft. It's un, un, unproportionately that's a lot of Indians there because India is the world supplier of brains. You and I also fall into this category of Indians. You like it or not, I know you hate Kohli, but we are part of Indians in the Western world. Uh, we because the world, they need to grow, but they are short of talent, hardworking people. So you are really required. That you need to remember that. So you are competing against Indians actually. If you are truly determining to achieve, go to the global stage, you are competing with Iranians and Indians. Uh, so where the world is heading to, one thing is green. Before I tell that, I have to tell you cannot be born in a better time than now as an electrical engineer. In the 90s, I would say it was a bit boring to be electrical engineer. But now, due to this climate pact in Paris Climate Pact and climate initiatives, global warmth, the whole world is going towards green. It's a green shift. So the existing technology is being retrofitted by new technology. They remove, for example, remove the induction machines because of high losses, and they put permanent magnet machines. This is now happening because of uh, the penalties the companies get, and then also new technologies are coming, like because of the emission reasons, you get electric vehicles, for example. That's a classic example. And planes are getting electric, ships are getting electric. So there's a lot of demand for electrical engineers. So you are born in the very good time. Of course, Corona is a different topic, but in a broad scale, you are born in a very good time. So green is one thing, and then reliable products. That is because, as I mentioned here, non-conventional, conventionally non-electric products are becoming electric now, like the aeroplanes or the mining industry. Then reliability becomes so critical, and also electrical engineering domain helps make things more reliable also, because of the diagnostic tools you can monitor from remote locations, predictive maintenance, all these buzzwords. So green, reliable, and digital. Analog controls are very limited. Everything is getting digital, embedded real time simulation hardware. It's all getting digital, and things are getting more complex. So you need more intelligent algorithms, and then all interconnected with 5G, IoT, and all this, right? So these are the as far as I see, these are the mega trends, and all these mega trends are connected to electrical engineering. So you think about these things and position yourself to a area where what is passionate to you. You will be in, your future will be assured. Then the tech skills to focus now. Number one is control theory, which I didn't take very seriously. I really recommend you to take control theory very seriously, and also with Simulink. There is no control theory without Simulink, right? You learn control theory only with mathematics, you're not going anywhere. You need to learn Simulink uh, to plot the board plots and root locus and uh, shaping a feedback loop. You must know that. So if you graduate without knowing that, you haven't done a good job, right? Keep that in mind. And then mathematics is pretty important. I was always thinking when I was in university, what's the point of learning mathematics? All this matrix, Laplace. Uh, that's because of the things that we haven't seen the engineering product development. Now I see it's mathematical theories are super important. And make if there's a possibility, try to learn some mathematical software like Mathematica, Maple, or open source tools. These will come handy. Say you can do a partial differentiation manually, right? But try to do it. You can find some open source tools. Try to do it in the software also. That will make your life easy. Not in the exam. Of course, you have to do it manually in the exam, but in the real world, you don't do the long 4 or 5 page calculation. You do use these tools. As long as you enter values correctly, you will get the result correctly. Then I cannot cannot overestimate overstate the importance of simulation tools. For example, I'm giving some examples. For example, to to learn drives, you need to have Simulink. Electric drives, make it a self project to develop a V by F controller for induction machine. You find enough resources online to do that. Build, but that could be a self task for you if you really, because then you learn the basics of implementing a Simulink model. And devices gate, if you are interested in devices gate drives, this Plex spice based simulation, very important. uh, Hands-on experience, it's a key. It's make sure that you choose your internship wisely, right? That's I think that was a turning point for me. I was a bit stubborn to choose a internship that I liked. Department, I mean, it was a new place. It aligned with my interests, and but it was a new place, and the research in the university was not very happy with that. But that was a turning point for me. So if you are really interested in hands-on electronics, power electronics, embedded systems, try to get a position in Vega, for example. I don't know any other place because I'm outdated. The place I worked was not existent any longer in Sri Lanka. Um, so keep that in mind. And also there are enough free online courses. Now this is also a threat, right? If you go to NPTEL, probably you have this is NPTEL offers all the best. It's insane to see the resources you have. It's from the best universities in India, IITs and IISc. It's you can do your whole engineering degree from home. Every single thing you can find over 200 subjects. You can, it's like a buffet. You can cherry pick. Okay, I want to learn this and that, but you might get certificates also in certain things, but there is no excuse that you don't know in the modern internet age, right? There is no excuse any longer. And especially I this this course, when I wanted to qualify for this PhD, I took this course. This is from Texas and Arlington University, and this course is so interesting that they even teach you the hardware. You program the hardware, and they have a fancy software to grade my program in the hard embedded system. So there is no truly an excuse if you don't know these things in the modern world in internet age. And also now this tells you one thing: are you wasting your time in Moratuwa if you can learn everything online? What do you think, Lakshane?
Like in our university, like all the lecturers like giving their best in academics. Like if you can have more practical related stuff, it will be very much better. Like workshops
Yeah,
and kind of a thing.
yeah. I think I should not insult the professors. I am a product of Moratuwa. I am very proud to say that. But the internet age is making the conventional university concept bit redundant, right? So you keep this in mind. One good thing with the university is that you get a certificate from Moratuwa, and Moratuwa is well recognized. But make sure to get the best out of university, you have good relations. One thing you cannot do online is to have relations supervision from professors. Make sure that you build good relations with your professors, learn from them really well, respect them for sure. You do that already. Get good supervision and mentorship from them, because they have seen what I am telling to you now. They have seen the world. They have done a lot of interesting engineering work in their lives. Build your relationship with them, right? Don't think like a tuition class. You need supervision, you need guidance. Your professors are your patrons. Keep that in mind. That is something you cannot do online. Number two, labs. Take your labs very seriously, which I did not do. Learn your lab. Take them very seriously. Do it on your own. I'm sure you guys are still. I don't know if you still do that, copying the coursework. It's a pretty common thing which I did, and it's you feel like it's a waste of time to write the coursework, right? I I I mean I should, if I had the chance, I would have done the labs again. Do the labs on your own. Of course, it's a teamwork, but try to understand every step. Ask questions. Understand the labs. Something that you cannot do online. Three, get involved in a lot of hands-on projects, individual as well as team, where you cannot do online. Teamwork is something you need to learn. No matter how good you are in engineering, at the end of the day, you are working with humans. If you are weak with humans, you will have a miserable career, right? Involve yourself with a lot of teams. Develop things together. That's very important. So these are three things that will make you stand out compared to an online student. Of course, now you are learning things online due to COVID situation. I'm talking a bit forgetting the COVID situation, right? Uh, so then we move on to the next thing is transferable skills to focus. Now, some some people call it soft skills, but this is a new word for me also, transferable skills, because the meaning is that you can transfer them from one job to the other. That's the purpose. So if you know this transfer, that's the meaning of that word. One thing to remember, that if you are an engineer, you are a report writer at the end of the day. No matter what you do, you have to write a report. Writing skills are pretty important. Keep that in mind. Write it concisely, to the point, not like beautiful literature essays. To the point, very straightforward. In yeah, active voice or passive voice doesn't matter, but very short and straight writing skills. And good engineer is a report writer. Good engineer is a convincer. You need to convince, right? Uh, your design, I think that's one challenge that some of the engineers come from our universities, that we are not very good talkers. We need to learn the art of convincing others with your design, your ideas. Otherwise you will never win. Your idea will never win. So I'm indirectly saying the importance of communication skills, but communication alone will narrow it down. I'm talking about conviction. Learn the art of conviction, uh, and that's pretty important. And if the most important skill, I would say, for the success as an engineer and as a human being is the skill of relationships. uh, Relationship skills is not networking skills or contact skills. Like these things are short-minded, short-sighted. Relationships will go long distance. It will remain. People will remember you for your honesty, your dedication, your responsibilities. So that's why you need to get involved in a lot of teamwork and extracurricular activities. One thing I have to tell that remember, you the opportunity of learning in a public state university is not only about free education, but also you get to see some sort of a cross section of the country. You studied probably in one school. This at least applied to me when I studied in school for 13 years. We are pretty much the same people in the school. But when I come to the university, I see a larger cross section of Sri Lanka, and Sri Lanka has a lot of class layers. About 15, 20 different layers of classes. Try to associate with everyone. Try to develop your own skills to deal with anyone. Maybe it's a Tamil or a Muslim or a Sinhalese or a burger from Colombo, from rural areas. Get that opportunity. If you study in a private university, you don't get this opportunity. In private universities, typically again it's limited class. You don't get this opportunity. You in a state university, try to broaden your horizons, and that will improve your people skills. Try to do that. Don't stick to your schoolmates or your same class attitude friends. Try to find other friends. That should be one of your targets in the 4 years. uh, and now I'm getting more philosophic now. uh, I'm here targeting some mindset challenge or traps that typically undergrads fall into. uh, in retrospect, I come with these things. One is the once you are finished with your degree, you are without a track. From your grade 1 to in primary Montessori, if you have been to Montessori, from Montessori to bachelor's degree, you have a beautiful track. You go to grade 1, 2, 3, 4. You don't have to do anything. You anyway go there, right? You are promoted. You didn't have to apply for grade 2. You didn't have to look for a job, look for a class. If you do well, you are going to grade 2, 3, 4, 5. You do the scholarship. You go to a good school. You do O levels well. You do A levels well, and you go to the university. So now the track is beautifully formed. After bachelor's degree, still people follow the track. Okay, then what's next? Do a master's, do a PhD. Then what's next? This is a challenge because you you and I, we all came following a track, and this track ends for most of us at the end of bachelor degree. Key, so you have to be aware of this, and maybe you still follow mega masters, where masters go. Okay, they are doing this, so I'm also doing this. But keep your freedom, keep your mental freedom to do what you like to do, because this lack of track after the bachelor degree might be challenging, because we are used to follow a track all the time. This is not only for us; it's for many developing country students. The second thing is short-term focus. I told you before that you are a Ferrari. You are a born Ferrari. You are really clever, but you need to tune it, and this tuning takes time to get the optimal performance. That's how I see. If you look at the short-term focus, okay, I want to get a good job or good salary and good title, good salary package. Probably you will probably you will not get the full potential out of yourself. This point is tied to the second one, getting married to the Arachi. Uh, this Arach is like, say, a beautiful girl from the village. Uh, she wants to her parents make her marry the rich Arachi in the village. You will get all the luxuries. You will get the prestige, but your freedom is gone. Maybe you will not develop or you will not realize your potential ever. You are bounded by Arachi's big mansion. You cannot be developing all the tuning your engine all the time. But how I say is that it's too early for a graduate to find an Arachi. Siemens could have been my Arachi. That it's so safe there. I mean, it's a nice place, but I thought there are more things for me to learn. Be mindful about it. For big companies will give you nice salary packages, nice titles, prestige, but you have to prioritize. If you want to be an engineer, what are you going to learn in the first 5 to 10 years? If you do not consolidate as an engineer in the first 5 to 10 years, you have to forget your career. Uh, that is, I have seen, if I talk to my batchmates and to seniors, those who have gone to big companies, maybe overseas or maybe in Sri Lanka, after 10, 12 years, they don't call themselves electrical engineers. Maybe it stands only in the CV because they are so specialized or they have forgotten their theories. They have not applied, they don't remember anything, but they are well paid, they are well settled. But that also pays a risk. For example, so if someone has started working in Sri Lankan Airlines, people have challenges with this COVID situation. If they are uh, they are firing people or not, I don't know if they do it. But what if you lose your job after 15 years and if you have not consolidated your engineering theories? So there's a risk if you do not invest in yourself. Make sure that you take this a bit seriously. And then another thing is migration. Going to another country, going overseas, does not mean success. Is something I have to tell honestly. People who go abroad always post photos on Facebook that they're having a beer or enjoying in a park. But the truth may be different from what you see on Facebook, right? People are. I know some very good friends who are trapped in foreign countries. They they are doing very bad overseas, but they cannot return also be due to other circumstances. So there are multiple ways to go abroad when you are a graduate from Moratuwa, but that does not ensure you success, right? Keep that in mind. Uh, and finally, what I have to say is you have to own your career. Don't don't outsource it to the big company or to the government or to a big institution. It's your career. You decide. You have to take ownership, or it's very easy in 15 years you regret. Uh, finally, I have to tell that not everything is uh, not everything is under your control, right? Most of the things are beyond your control. So fortune plays a big role, and with this regard, I want to remind this person. Do you know who this is? Jayanaka, do you know him?
No, sir, I'm not familiar.
Yeah, he's a retired CEO from General Electric. Uh, he's known as Jack Welch. He was the CEO for 25 that much years in GE. By the way, GE is the company that Thomas Alva Edison started, and this man is was responsible in making it a global giant. Jack Welch. I have seen one interview from him. He told one thing that stuck in my mind. When he interviewed people, especially fresh graduates, he said he looks at two things: IQ and generosity gene. IQ is a buzzword, but let's say cognitive skills and generosity gene. You are born with the first one. You need to tune it for sure. You are born with it. But the second one, generosity gene, that's I think that plays a very important role in tuning your fortunes, improving your fortunes. To be generous, a person who likes to give. Generous is not about posting, giving some money to some poor person or giving books to a poor person. Generosity is beyond that. You are prepared to serve without any glory. You are prepared to give, prepared to improve the surrounding, and that costs your time and energy. And that takes this ownership mindset. You think, okay, there's nothing. For example, organizing this event, it does not give you credits. It does not give you study points, but you do it for the benefit of several people. That kind of, if you do this selflessly, that will improve fortunes, and I can guarantee that. That concludes my presentation. I think it took quite a long time. You can contact me like this through these ways. Probably yeah, these are the questions I got yesterday. Uh, should, what do you say? Should I go through these questions or should I go through the platform?
We thought of getting the question through the Zoom chat. We can go. We can do the both of the systems,
Okay.
if that's okay.
No problem. Should I right? So maybe I will start with this set of questions.
Okay.
Yeah. What is the postgraduate potential as an electrical undergraduate? I think I prepared a couple of slides. Yeah. There are there's a multitude of opportunities as electrical graduates. Uh, I'm talking from my interest point, power electronics. The ones uh, the ones in blue, they have very good master's programs in power and drives. In TNU, of course, I'm biased because I'm here. But if I knew this when I finished my bachelor's, there is this university in Aalborg. Now that's another thing that you have to remember when you go for postgraduate studies. Don't look at the university name, but look at the program, and also because in our domain, this Harvard, MIT, Stanford, these are world famous universities. But when it comes to power electronics, electric drives, particularly, the world leading universities are it's a different set. Aalborg University is a very good university. It's probably the top three universities in the world for drives. KTH is very good. Nottingham University of Nottingham, it's the largest university in Europe for power electronics and drives. Eindhoven in Netherlands, DTU, any university in Nuremberg, Germany. There are multiple universities in Nuremberg, Germany. All should be good. I mean, I know one or two because Nuremberg is the Silicon Valley of Europe, and they have really good universities. They develop the industry in Germany. Keep that in mind when you go for a master's degree or a PhD degree. Research hot applications. There are multiple hot applications. Uh, yeah, this side shows it's too many details for you, but we can show you some applications just to tell. These are the applications. Multiple applications, research and development applications for electrical engineers. Sorry, only for power electronics. Only for power electronics. Imagine power systems, high voltage. That's you have enormous opportunity, right? Enormous opportunity. It's what needs is your will. Uh, to to answer that question, yeah. Let me see if I have missed. Yeah. How to get industrial experience except except internal experience within the undergraduate period. I don't really get the question, but suppose you want to do a part-time job. uh, if you have the possibility, do that. I mean, to do a part-time job, not as a tuition teacher or someone, but in an engineering in a development place. If you have the opportunity, why not you do? You get the experience without disturbing your studies. What are the job opportunities and fields for electrical engineers in other countries? I think I have covered that point in the presentation. What do we want to uh, become a chartered engineer? I myself is not a chartered engineer. I'm sorry, I cannot help you with that. What are the qualifications that we need to satisfy to reach global status as qualifications? I would rephrase this as competencies over qualifications. It's important to know that qualifications will not bring you anything. Maybe you get a job, first job, yes, but at the end of the day, which competence you own, that's what matters, right? I can show you people with PhD who have very little competence in industry, also in universities. But what matters is the competence. You think when you take a degree or a course, you think that you are carrying a backpack and you want to collect tools tools to your toolbox. Every course you take, look at the learning outcome, and it should be a toolbox. Otherwise, no point of taking that course. That's how I chose my subjects in the master's degree. I went to that professor. There are some subjects that clashed. I asked, which subject can I take self-learn? Which subject I cannot? I need supervision. The subjects that I could self-learn, I never took. I never self-learned either. But the subjects that need supervision, need real expert teaching, is the subjects that you should take. If you can read something by reading a book, learn something by reading a book, don't spend 2.5 credits on that. But qualification, it's the competence that matters for the global stage. But this now this is something I want to let. So I'm going to tell you another secret. Electrical in big electrical engineering companies, as I told you before, electrical engineers are normally focused on power. And then you have the control engineers. Then you have the electronics engineers. And then you have the software engineers. In certain products, you need all 3-4 disciplines. The problem is there is no enough competence who can marry all these 4. The companies, big companies, are having big troubles because the people don't talk each other's language. Software guy does not understand what power factor means. the electrical guy does not understand how object-oriented programming works. Electronics guy does not understand both worlds. So to develop a product, there's a lot of arguments, challenges. So the secret is if you could learn to be good in all this four, you will be that's that will guarantee you a job for sure, a long-lasting job. That's a secret. Uh, if I hope to work in Sri Lanka, is it a good choice rather than go abroad? Definitely, I mean, it's our utmost duty to serve our motherland. Definitely. The question is, does that allow you to realize your full potential? That's your choice. But if I have the opportunity, I would come to Sri Lanka uh, without argument. What is the current stage of electrical engineering field in Sri Lanka? I'm a bit outdated with that. I'm sorry about it. What kind of issues in electrical engineering field are happening meanwhile, which are not solved yet? I think this answers. Uh, Either they are solved, but they need better results, but or they need new disruptive solutions. So this slide will show you give you the answers. What is uh, what is the possibility of implementing a nuclear power plant in Sri Lanka? I'm not an expert in nuclear or power generation. I have an opinion though. My opinion is that nuclear power is the world's cleanest, cheapest, and safest technology. Safest. Maybe you raise your eyebrows. If you look at the deaths per megawatt, nuclear power plant generation is the lowest, and it is definitely the cheapest, and it is also clean, very clean compared to coal and thermal. Why? Because all the residues can be collected to a small tin. So unlike in coal where you emit it, right? So you have it collected everything. How you dispose it or not, that's a different story. But possibility of implementing, it's a political and feasibility. It's a different topic. I'm not qualified to answer that. But in a technical point of view, it's the way forward as far as I see. What should I follow, and what are the most important skills I should have improved to become creative and innovative electric? I mean, creativity is. I mean, it's you cannot learn from a book the creativity, right? But my experience is creativity. You become creative once you dwell into one topic and you get ideas. Say you are working on your bachelor thesis, and you burn your brain to get some ideas for hours, days, weeks. Once you do it, once you fight battle with your topic, you get ideas, and that's engineering creativity in my mind. But you need to dig deep into the topic. You cannot be creative from outside. You need to question, go solve something, simulate, and ask your professors. Then you get ideas while reading. That's engineering creativity. Innovation is a different topic. I mean, it takes another 2 hours for me to talk about innovation. But it's I don't. I mean, these are buzzwords. If you say innovative engineering, you can. I mean, innovation is it's a different game. We have to have up-to-date knowledge regarding modern tools and software. What are the most relevant software related? I think I touched that. Improving the practical knowledge with the theory knowledge is a must. Give your thoughts regarding this. I think I covered that also. What is the current development stage about autonomous vehicles, EVs, renewables, microgrids? I mean, each topic is about 2 hours. Uh, and also, I'm not an expert to talk about everything here. I can touch briefly about EVs. Uh, this this slide lecture I attended recently by Dr. Ajay Pai, who is in Munich. These are the technical challenges when it comes to EV, electric vehicles. Efficiency is it's the key. It is the key of electrical engineering. EVs, every 0.5% means longer range for the same battery, and efficiency means less thermal uh, uh, emission. That means cooling is easy. Less energy for cooling, and also it becomes dense. So efficiency plays a role. Low failure rate, that's high reliability, operating environments. So these are the technical challenges when it comes to EV. Uh, I can briefly touch about like microgrids. It's, uh, I mean, the ship system is a microgrid. Microgrids do exist now. So now they want to bring it to the land. Uh, it's a big topic. Machine learning, it's a hot topic. Uh, that's something I have to mention, that machine learning, artificial intelligence, all these buzzwords, the grounding principle of all this is nothing but statistics and probability. So those are the grounding mathematical principles. Based on this, you use algorithms to do machine learning, big data mining, and AI, and all this. So keep that in mind. Learn your mathematics well. As undergraduates, how can we grab the opportunities which are given from online learning platforms like I think I touched that point. Uh, have more workshops and projects, mock interviews for students. I highlighted this uh, because I want to touch upon this the interview part. You when you go for the job interviews, you have to be well prepared. I was not well prepared when it not about technical things. You know your technical things. Be prepared about that company and what they are trying to which position you are going to be hired. That will I mean, when you go to this big one thing you need to remember when you go for your first job interview, you are the David, whereas the company is the Goliath. Because in Sri Lanka you don't have much opportunity, much competition for the supply side. There is only a few companies who would hire you, whereas there is a lot of graduates coming out. So then it's the advantage, the bargaining power is with the company, not with the job applicant. Then they promise you fancy things. They will. I mean, it's there can be you can be carried away by the job advertisement and the interview process. You have to be very mindful with that. You need guidance. You need to have good relations with your professors. Talk to them. Uh, that's pretty important. Encouraging students to do extracurricular activities and give enough space to be relaxed, creative in between. Well, uh, it's very personal also if you like to do these things or not. But as I told, it's very important to build the relationships with your batchmates. I mean, if possible, cross your university and make relationships with other universities also, because this is a golden opportunity for you. Imagine when you grow up, when you graduate after 4 years, uh, you have friends, doctor friends, lawyer friends, humanities friends, psychologists as friends. If you build a big network, when you grow up, you will have a lot of, especially if you live in Sri Lanka. So get best use of your university life, create memories, and also while doing extracurricular activities, you can build relationships. So that's how I see, and that covers the questions. Do we have more questions,
Yes,
Jayanaka?
sir. I thought we'll go through the questions that was given in your poll.
Yeah. Why? Let me look at. Let me share that instead.
Can I remind the audience that there's a poll? I think the link has not been posted on the chat, I guess.
Yeah, please
So,
do that. Should I do that?
Lakshani will do.
Let me.
Lakshani, can you put that on the chat for everyone?
Yeah, sure.
It's okay. I can do that.
Okay. You can post your questions through the. Hello.
Yeah, I hear. I hear.
Okay. The audience can direct your questions to Engineer Aravinda Perera, and also I would like to remind you that there's also our engineer Naudana Kankanange also in the meeting, so you can ask any question if you want about the chartered engineering aspects, or about the CEB or the Sri Lankan state of the electrical engineering industry. You can use this platform and you can ask your questions using that platform. I would very much encourage everyone to ask questions, much questions as possible, because this is a great opportunity to get more insight into what we learn, because it is not a good practice to learn things without knowing what we are learning them for. So I think it's better you ask as many questions as possible. Currently, there are 3.
Do you see
Yes.
my screen now?
Yes, sir, we
the
can
question.
see it.
Yeah. Okay. Great. So let's take the first. Why did you feel that you want to do a PhD after working in industry for some time? That's I like that question. Want to address it. I have this philosophy of learning based on a motivation, right? I didn't want to do a master's degree after I finished my bachelor degree. Also, I wanted to buy a car. While I was doing my bachelor's degree, I wanted to buy a car. So, but then when I started the job, I realized I got the motivation to learn further. Then I found a job in Siemens. It's really cool, but then there were some black boxes that I had to deal with, and I'm not very good in dealing with black boxes. Of certain things that I was not allowed to do, certain things that I had to assume. So I collected some things that okay, I should learn these things. I tried to do it on my own in the evenings, but no, it's no chance. You need supervision. You need to do it by your own. So that was the motivation for me to go for the PhD.
Yes, sir.
Right. Then we have a new. So isn't hydro and wind power? Yeah, that's the most popular question. Isn't hydro and wind power cleaner than nuclear? If you look at if you forget the construction and during the operation and maintenance, maybe yes. But if you look at the full picture, construction of hydro is not bad. But when it comes to wind power is one of the worst sources, because to build that tower wind turbine, it it needs a lot of resources. lot of minerals. And I saw one research showing that the number of uh, material, the kilogram material per kilogram material per kilowatt is largest in wind power. So you need a lot of uh, it's clean. Maybe it looks like it doesn't emit anything, but it to manufacture such wind turbines, it doesn't look promising now. But imagine in 100 years, where the world has moved from world generates 50% of its power from renewable energy. Maybe that statement is correct. What I'm the my notion is for the present time. Things are changing. Imagine a ideal world where all energy is produced by renewable energies. Then wind power can be cleaner. But for the at the point of time, wind is not clean if you look at the full picture, because manufacturing of a wind turbine is not clean. So same applies for solar. Hydro, it's an interesting point. Hydro again, not manufacturing, the construction of a power plant is an enormous civil work. But also there is one thing I learned recently, that hydro, uh, when you have hydro, this water reservoir, there is algae under the in the on the reservoir bed that emits a lot of carbon dioxide. I don't know the amounts, but surprisingly, hydro emits CO2. Uh, this is I don't have the numbers to compare, but it's not as clean as you think. So why did you feel that you want to do? Yeah, I answered that. Can we directly apply for? I think I answered that. What are the requirements to get a scholarship for MSc in Norway? Are those scholarships available in forms of research? Mm, in Norway, you have to apply in December. There are two. I'm a bit outdated here because I applied in 2010, 9 and 10. You what you get, it's a bit competitive because you have 10 seats open for people outside Europe. Or yeah, people outside Europe, it's only 10 seats, and then you compete with. It's a big competition for that. Still, you don't get tuition fees. Sorry, you are exempted from tuition fees, but living expenses must be covered. So you might be able to find a part-time job. That's the structure of Norwegian master's program. Scholarship. There used to be some scholarship program, but it does not exist any longer. As far as I know, you get only the tuition fees exempted, which is the biggest portion. Living expenses are also pretty high in Norway, but you might be able to find a part-time job. At least I managed to find. I was cleaning dishes during my masters, so it's possible. Anything is possible. It's just, but there are. I mean, if you go to US for there are other schemes in Norway and Sweden and Denmark. This is the scheme that you get the tuition fees exempted, but the living expenses are not given unless you apply for Erasmus Mundus program, which I didn't know at that time. Keep that in mind, Erasmus Mundus. Then you get both. You get, in addition to the tuition fees exemption, you get living expenses. It's about yeah, 150 or 180,000 lakhs rupees per month. It's a decent amount. Yeah, I think that's all. That covers all the questions, right?
So those are the questions that came up.
Yeah. Yeah, that completes the questions, right? Do we have more questions?
There's a
We have
question,
one.
sir. there's a question, what is the current stage of electrical engineering field in Sri Lanka? You or Naudilsa can answer that question.
Yes, Navodana
let
is
me
the perfect
answer.
candidate.
Yeah. Actually, unless the COVID situation, electrical engineers, we have very good opportunities in Sri Lanka, and most probably within few days or few months, we are going to recruit electrical engineers to CV also. Nowadays, applications are called to mechanical engineers and civil engineers. Most probably, within short period, vacancies, we will be calling vacancies for electrical engineers also, bulk amount. And we have very good opportunities in other organizations too. So unless the COVID situation, actually, electrical is very good in Sri Lanka. And there was a question that about how you are becoming a chartered engineer. Let me answer to that also. So for that, basically, you need to complete 24 months responsible experience and 24 months recognized training after you graduate. Normally, once you have graduated, you have to take the associate membership of IESL, Institution of Engineers Sri Lanka. So then afterwards, you have to gain those experience and training. Then you can sit for, there is a examination called B paper, and afterwards A paper and Viva. During that Viva, we are looking five key competencies. You have to cover those competencies during your training time. Afterwards, by evaluating yourself, chartered engineer qualification will be awarded. This is very short answer. We can give a good explanation in a coming event like this. Because of the short period, I just went through that. Actually, it is a very complex process. We can explain it further in the coming session. Over to you, Jack.
Okay. Thank you, dear sir, and thank you, Engineer Aravinda. It was a quite beneficial evening, I would say. Sadly, we have to conclude the Q&A session because we have a time constraint as well. So before we conclude this event, I would like to invite Dr. Tushara Damayanti to give us her aspects and insight about this event and also about the electrical engineering field as a whole. Madam.
Thank you. I think you can hear me.
Yes.
Yes, sir.
Mr. Aravinda, so I think you are a batchmate of Dr. Asara.
1 year junior.
Okay, so actually nice to meet you. And so I joined for a short time because I had some other plans for today evening. But when I heard your talk, it was really impressed. So I was to stay until the end of session. So actually, I believe that you shared very genuine thoughts of your experience and your thoughts with mainly our audience is undergraduates. So I believe that it is a very good motivation for them, and maybe they got a very good understanding about the opportunities that they have, because almost many of our graduates believe that as electrical engineering graduates, they have to join CEB, or only they have to do some electrical engineering related jobs. But this is one example, because not only that, all around the world, we have a lot of graduates, our department graduates lead in the world. So there are a lot of opportunities. So, but only thing is that, as he said, because with many of his views, I am totally agreed. As he said, at university, what we can give is only the theoretical knowledge and some kind of practical exposure. So, but thinking beyond that is the success of engineers, because engineers means that you have to think beyond what you learn. So I think if you are ready for that, there are a lot of opportunities. So not only in Sri Lanka, in abroad as well. So therefore, this talk was really important for them. So thank you very much for sharing your ideas. And also another thing that something like, because some of our people are thinking that studying here and going abroad and settle there is the most satisfactory life. But as you shared your experience, we have also experienced that living, because we have also lived long period abroad, but that is not the satisfaction, because there is physical comfort, but we expect that satisfaction and happiness, those are the most important things. So that is in our country, that is in our motherland. So you can go, you can experience, you can serve for the world, but finally your destination should be here, because you can have your satisfaction and all other achievements in our country. Right? So I am not going to talk long, because I wanted to thank you. Thank you very much, Mr. Aravinda. And also we wish you good luck for your studies as well. And we wish that you can come to our mother country and serve us as well. Thank you very much.
Thank you very much. Thanks for this opportunity. We can. I'm open to take another lecture to make more technical things as a knowledge sharing session. Please feel free to reach me, and I'm thankful to Navodana, my batchmate, and Dr. Asara, who is my senior. Keep in touch, and good luck with your work. Thank you, Dr. Tushara.
Okay,
have a good day.
Thank you.
And
Yeah.
so we have another questions directed by the audience. Can I ask it also?
Yeah, do that. This is
Okay.
the forensic.
Okay, so, yes, yeah.
This forensic electrical engineering topic, is that
Yes,
true?
Yes.
Yeah. Okay. This is no. I as far as I know, forensic word comes when it comes to is related to a judiciary process, and I am not aware of this. I mean, it's an audit that has to be done when it comes to if it's related to a electrical judiciary process. Then maybe it's policy related or audit related. But I have never heard about such a topic, at least a research topic. But definitely legal aspects are there. For example, when you write a patent, it's not forensic, then it's called IP, intellectual property. Then you need lawyers who understand technology. It's not easy. You don't find many of them. So when I was involved in writing patents, it's lawyers who had no understanding about capacitor or a voltage. I had to tell them how to write the claims, and that is another domain. But forensic is to file a lawsuit, and that, no, I have never heard about such a engineering field.
Okay, sir. Thank you for that answer. With that, we have to conclude the Q&A session, and because please give us your feedback on this webinar using the link given in the chat. Lakshani will post the link on the chat before we conclude the webinar session. I invite the Vice President of the Electrical Engineering Society of University of Moratuwa, Mudita Senararatna, to deliver the vote of thanks.
Hello everyone. So it's a great pleasure for me to be in this audience and express the appreciation of your inspiring presentation in innovation, building the future from the Sumanadasa Building. So the title itself quite unique to the University of Moratuwa, but the motive is to share the industrial experience and exposure for the young blooming engineers. And each engineers promoting creativity, soft skills, and inventions and innovation, which drive for the apparently the entrepreneurships as well. So during this chapter of this webinar series, Engineer Aravinda Perera has brought up his years of experience, researches, and interest, and in an interesting way to enlighten us in this evening. And I believe this whole content is timely and valuable because being in this era where everyone talks about creativity and inventions and innovations and entrepreneurship, so basically it drives many value to us as undergraduates. So on behalf of the ESOC of Department of Electrical Engineering, University of Moratuwa, I may express my sincere gratitude to today's speaker, Engineer Perera, and Engineer Naudana Kankanamage, and Dr. Razara, Dr. Tushara, and the organizing committee of this event. And I hope that, as Dr. Tushara mentioned, that you will join us with in the future as well in the coming up sessions. So thank you very much for everyone joining with us in this first chapter of this webinar series, and have a nice evening. Thank you.
Thank you. Have a good day all. Bye-bye.
So now we are hereby concluding the first webinar of the Tech Talk webinar series with the hope of meeting you all again with another innovation event. Signing off, I'm Eng.Aravinda. Stay safe and good night.